All right, well, let's try this out. I added my API key, so let's see if this thing actually works. Okay, first we get an error here. No module named Pydantic AI. Let's see if it might have forgotten to actually add that dependency, or I might just have to run a UV sync. Okay, so, we could research this, we could figure this out, but honestly, the simplest way is to just copy this. All right, we'll open up Claude. I'm just telling it, getting an error, trying to run the pipeline, and then I just paste in both my invocation and then the trace back here. Let it deal with fixing stuff. Yes, I will allow adding this dependency. Okay, so basically just had to add the Pydantic AI dependency. Well, let's see. I'll keep Claude open. Okay, so it's running the fetch step again. All right, we got 913 new articles. It's actually been 2 days since I recorded the fetch step. So this isn't a huge amount of articles for 2 days, but also today is Saturday. And in general, I found that on the weekend, the volume of news articles tends to be a lot lower. During the week, it's a lot higher. So that kind of creates some natural fluctuation. And that's also likely why we saw those fluctuating costs when we looked at the dashboard in Google AI Studio. And yeah, it looks like it's actually doing the triage. What I might do afterwards is maybe add a little bit more verbose logging. It's kind of nice to be able to see where it's at, which of the batches we're processing right now, and so on. So there's a lot of different ways to do that. I kind of like the idea of maybe adding a verbose command line argument, so we can specify that and run it in verbose mode, or we can, have the more terse output by default. It's a good sign that it's taking a while, though. That means that it's actually making some calls. If we set everything up, then I should be able to go to the Google AI Studio logs page and see those API calls. In fact, let's maybe do that while we're waiting. All right, this actually looks really promising. So here is my API key, and here we have a whole bunch of these requests. Each of these is a Gemini call. So the input, let's just click on this, and there we go. System instruction, right? You are a senior news editor, blah, blah, blah. So that's our system prompt that we added. And then here we see the model that we're using. So Gemini 2.5 Flash Lite. And then we have the actual user prompt here. So the text is, please triage this batch of articles. And then we have 0. So this is our index. This should be the article title. So Loop Capital thinks this chip manufacturer could more than double on an AI supercycle. And then we have a return. And then Astera Labs is among the best positioned companies to benefit, blah, blah, blah. Fine. And then here it's just chopped off in the middle of a sentence, or middle of a word rather, but that's totally fine. Then yeah, we have our key 1, we have another subject line, another body, key 2, and so on. If we scroll down here, we should see 40 inputs, so 0 through 39. And then we actually see the response down here as well. Here in the output, final result, we see this as function calls. So the way Pydantic AI implements these agent calls is using the so-called function calling mechanism in Gemini. It basically provides a tool definition for Gemini, and then Gemini can invoke this tool to pass in the response, and that's how they do the validation and everything. So it returns the final result with the decisions. So here we have this one we are keeping. This article discusses a specific company, Astera Labs, and its potential for growth driven by AI, which is highly relevant to startups and technology commercialization. We are keeping this one, and here's one that we're discarding. So this article focuses on China's domestic economic stability and growth goals, with only a general mention of tariffs and vague plans, lacking specific actionable signals for startups or emerging business models. Without looking at the article, that sounds very plausible, right? Here we have another one that we're discarding. while it mentions the chip industry, the article's main focus is the geopolitical threat to South Korea's chip industry due to regional conflict, not specific market trends or startup opportunities. So it's discarding a whole bunch. Inflation and interest rates, trade impact. Yep, that all makes sense. Here are some that we're keeping again. So at first glance, this all seems to be working just fine. Okay, so now we just have to wait for the results. And if this seems pretty slow, that's because it is. And we are going to do some optimizations later to speed things up quite a bit. But first, we want to see the fetch step actually finishing and working successfully. Also worth pointing out that sometimes if there's a problem, you might see a different status here. So you might run into rate limits, or sometimes Google's API actually has some downtime or things like that. So there's a lot of reasons why things might fail. We can also make things more robust later by adding some retries and things like that. But here we go. It actually just successfully finished. So I'm seeing it triaged 1759 articles. That's actually why it took so long this time. Remember, we had all the articles in the database from our last fetch run when we implemented the fetch step. And then just now we got another 900 something. So we had like 1759 articles total that we had to triage. And yeah, like I said, it kept a little over half. So 953, and it discarded 806. So that's very much the sort of ratio that I'm expecting, right? Somewhere roughly half. And you can dial this in more over time. You can update the system prompt for the triage step to be, more permissive, less permissive. This will very much depend on your specific use case. So let's quickly look at how things look in the database just to make sure that everything looks as expected. So again, we'll use the database plugin here. I'll just have to click on this. So we should now have a triage decisions table. There we go. So this references articles, and it has 0 or 1, depending on whether we keep it or not. We have the reason string in here, the run ID. So yeah, this looks perfect. So we just need to commit our changes. The only change here was that we added the Pydantic AI dependency. And actually, I like the idea of adding some more verbose logging because we had to wait quite a bit, and it's kind of nice to be able to see where you're at. So let's just do that while we're at it. Okay, I'm just going to say add a verbose command line argument that adds more verbose output when running the IDEA pipeline. For the fetch step, log a line for each page of results that we fetched. For the triage step, log a line for each agent batch call that we're making. That should be good enough. This should only take a few seconds, I think. And there we go. Let's try it out. Open our terminal. Let's actually do --help. Make sure it also documented this. Okay, there's nothing in the... Actually, I think I might have to do... there we go. Yeah, so this option is specific to the run step. So it's documented under the run steps help. And there we see verbose or -v. Either will work. So let's try this. This should be very quick because there should be barely any new articles to fetch and to triage. Oh, there we go. Yeah, the fetch, of course, will still retrieve the same number of articles, right? Because at the time we fetch them, we don't know if they're already in the database. So it always fetches 10 pages worth of articles, but then it should be deduping them when we actually save them. So in fact, we only got one new article since the last time we ran. And then we have the triage, and it's now logging which batch, the current batch, and the total batch count. And of course, it's only one because there's literally only one article to process, but I will just trust that this will log the right thing when we have more to process. So I think that's a nice improvement. Let's commit this. All right. With that, I'm happy with the results of the step.